At the top of LBM M4, a rocket carrying India's prestigious Chandrayaan 3 spacecraft, history was made in 2023. Chandrayaan 3 landed on the moon's south pole, making India the fourth nation to achieve this feat. However, what they uncovered has even Michio Kaku, the renowned physicist who championed space exploration, sounding deeply concerned. Our universe is a three-dimensional bubble expanding in a larger nirvana, a never-ending nirvana of 11-dimensional hyperspace, spaces beyond human comprehension, Kaku states. The idea is simple: you send a robot to land on the moon because the moon is stable, no erosion, no rust. The moon then builds a factory, producing thousands of carbon copies of itself. But what if something unknown is already there? Strange materials, unexplained heat, and possible structures beneath the surface have captivated the world. Stay with us as we dive deep into this lunar mystery that has gripped the global scientific community. The stars don't rush their secrets, and neither do we. If you're here for the long journey, Moro is waiting. Subscribe and step into the story. What is Chandrayaan 3? India's lunar milestone. Let's start with the foundation. India's Chandrayaan 3, launched by the Indian Space Research Organisation (ISRO) on July 14, 2023 from the Satish Dhawan Space Center in Sriharikota, achieved a soft landing on the lunar south pole on August 23. This marked the first time any nation explored that region up close. The mission followed Chandrayaan 2, which faced a landing setback in 2019. But ISRO's persistence paid off, solidifying India's role in global space exploration. Why the South Pole? It's a scientific treasure trove. The permanently shadowed craters hold vast reserves of frozen water ice, leftovers from the solar system's early days, potentially dating back 4.5 billion years. This water could transform lunar bases, offering oxygen, fuel, and hydration for future missions. That's why NASA's Artemis program, alongside efforts from China, Europe, and Russia, has its eyes on this region for permanent outposts by the end of the decade. Chandrayaan 3's success adds India to that race, proving that the moon's potential isn't just American or Chinese, it's a global frontier. The mission consists of three parts: a propulsion module, a Vikram lander, and a Pragyan rover. The propulsion module, orbiting the moon, carried the spectropolarimetry of habitable planet Earth shape, payload to study Earth's light, gathering data on atmospheric signatures. But Vikram and Pragyan did the heavy lifting on the surface. Vikram, standing 2 meters tall and weighing 1,700 kilograms, housed Pragyan, a 26 kilograms rover designed to roam and analyze. It was packed with advanced tools: laser-induced breakdown spectroscopy (LIBS), alpha particle X-ray spectrometer (APXS), ground-penetrating radar (GPR), Chandra surface thermophysical experiment (CHAST), and the Instrument for Lunar Seismic Activity (ILSA). These instruments studied the moon's surface composition, temperature, subsurface structure, and seismic activity. For one lunar day, about 14 Earth days, they operated from August 23 to September 2023, sending back data before shutting down due to the lunar night's extreme cold. Hopes of reactivation didn't materialize. Yet, in just 10 days they delivered game-changing insights: water ice, minerals, and then something far stranger: the unusual discovery. ISRO's budget for Chandrayaan 3 was around $75 million, a fraction of NASA's Artemis costs, showcasing India's cost-effective space technology. For global viewers, this efficiency highlights a new player in the moon race, challenging U.S. dominance while offering collaboration potential. The mission's data feeds into international science, including NASA's Lunar Reconnaissance Orbiter, which continues mapping the South Pole. Pragyan's onboard instruments, LIBS and APXS, began analyzing the regolith, the fine dusty layer covering the moon. Early results were promising: sulfur, aluminum, calcium, iron, chromium, titanium, manganese, silicon, and oxygen, all consistent with previous lunar missions like Apollo, Luna, and China's Chang'e. But then, something unexpected emerged: traces of material unlike anything catalogued on Earth, the moon, or anywhere in our solar system. This substance absorbed electromagnetic radiation in ways no known material could, behaving almost like a sponge for energy with properties that defied explanation. Michio Kaku, a key voice in theoretical physics and a US-based advocate for space exploration, described this finding as groundbreaking yet deeply unsettling. If this material formed naturally, it challenges basic physics. Its energy-absorbing properties don't align with any known mineral or compound, such as silicates, oxides, or even exotic lunar glasses. It could suggest new chemical processes from the moon's violent formation 4.5 billion years ago, when asteroid impacts and magma oceans shaped its crust. But its behavior, absorbing and potentially manipulating electromagnetic waves, doesn't fit. If it's artificial, the question becomes, who or what left it there? The implications. Pragyan's libs used lasers to vaporize soil samples into plasma, analyzing their light signatures, while APXS fired alpha particles and X-rays to map elements. Both flagged this anomaly, detected at multiple sites near Shiv Shakti Point, 69.37 degrees south, 32.32 degrees east. No database matched it. Earth's crust, lunar samples, meteorites and asteroids all remained silent. Kaku's concern stems from the implications. If it's natural, it rewrites chemistry and physics. If not, it hints at extraterrestrial or unknown origins, possibly linked to the moon's mysterious past. For global scientists, this is a puzzle. NASA has studied lunar soil since the 1960s, collecting 382 kilograms during Apollo. But this unprecedented finding, Pragyan's 2023 measurements at 70 degrees south latitude combined with ISRO's data, suggests a material with potential applications: energy storage, stealth technology, propulsion. But also risks. It could revolutionize fields like telecommunications or aerospace, but misuse or misunderstanding could backfire. Kaku is urging caution. The scientific community, including US and European researchers, is scrambling to replicate tests. Online chatter on platforms like X speculates wildly, alien tech, lost human relics. But ISRO's data is raw, not conclusive, leaving room for both awe and unease. A new layer to the moon's story. This material's discovery challenges decades of lunar science and ignites global curiosity. Next came another anomaly: heat signatures. Pragyan's Chandra surface thermophysical experiment, CHASTE, measured temperature variations across the lunar surface. Temperatures were expected: 50 degrees Celsius on top, minus 70 degrees Celsius at 20 millimeters depth, dropping to minus 10 degrees Celsius at 80 millimeters, typical for the moon's poles. But then, CHASTE detected heat pulses emanating from beneath the surface, fluctuating in a pattern that seemed responsive, almost dynamic. The moon is geologically inactive. No volcanic activity for billions of years since its crust solidified. So what's causing this? Initial theories suggest subsurface remnants of the lunar magma ocean, where heat could linger in isolated pockets trapped by the insulating regolith. But any residual heat should be stable, not pulsing. Could it connect to that unknown material, absorbing energy from solar radiation or cosmic rays and releasing heat? Or is it something structural deeper down, still active? The cavern discovery. Then came the biggest shock. Pragyan's ground-penetrating radar detected a massive cavern beneath Shiv Shakti Point, large enough to house a small city. The data showed a void with structured features, not natural chaos. Shapes appeared metallic, suggesting high conductivity, and their grid layout hinted at design: walls, frameworks, or supports, not random rock formations. SRO remains reserved, but the science is unclear. Could this be an extraterrestrial base? Ancient human technology? Lost civilizations? Michio Kaku is calling for an international coalition to study this. Caution first, before any disturbance. If active, those heat pulses could be systems, communication, defense, or monitoring. This isn't just moon dust. It's a paradigm shift. The future of lunar exploration. NASA's Artemis, China's Chang'e, and ISRO's Chandrayaan 4, planned for 2025 to 2026, all target the South Pole. The discoveries, water ice, sulfur, heat anomalies, structures, unknown materials, could spark collaboration or conflict. What's next? More missions, more data. But these discoveries demand care. Tech, ethics, philosophy. The moon's South Pole awaits. Will you be there? Subscribe tomorrow to follow Korean 3's quest and unlock the universe's secrets.